In section 6.2, we'll be solving quadratic equations by factoring. But before we get into the solving of equations, we need to establish a very important property. It is called the zero product property. And the idea here is that if we have these two numbers, a and b, they can be any real numbers. If their product, if when we multiply them together, we get 0, then it has to be the case that at least one of the two numbers, either a or b, or possibly both, are equal to 0. And if you're skeptical about that, you can pause the video and try to come up with two numbers, neither of which is 0, that multiply to be 0. You can't do it. This is a very, very important theorem for our purposes because it will allow us to solve a quadratic equation by the use of factoring. Let's go back to the arrow problem that we looked at in the last lesson, where we were shooting the arrow into the air, and it was modeled by h of t equals 64t minus 16t squared. We asked the question, when does the arrow hit the ground? Well, logically enough, we knew that one of the times was 0 because we were launching from the ground. And we found, you'll remember that we found that the other time was 4 seconds. We did that by creating a table of values and graph it and plotting the points and seeing the construction of the parabola. This time around, we'll do it by factoring. First thing we'll do is we'll replace that h of t with 0 because we're interested in a height of 0. So we have 0 equals 64t minus 16t squared. We'll factor by GCF to pull out a 16t from both terms. 64t divided by 16t gives you 4. So that's where the 4 in parentheses is coming from. 16t squared divided by 16t leaves you with t. So the common factor of 16t leaves behind a second factor of 4 minus t. Each of those factors gets set equal to 0, and we'll solve for t. So we'll take the first factor in the original right-hand side and set that equal to 0 and solve for t, and that's pretty simple. 0 divided by 16 is 0. There's one of our solutions. That's when the arrow was just about to be shot up into the air. We'll take the other factor, 4 minus t, and we'll set that equal to 0. And we'll solve. Subtracting 4 from each side will give us negative t equals negative 4, and that's how we arrived on the second solution, that t equals 4. Let's do another example. Here we have x squared plus 6x minus 16 equals 0. We're looking for two numbers that multiply to make negative 16 and which add to positive 6. Those numbers, you might have realized very quickly, are positive 8 and negative 2. 8 times negative 2 is negative 16. 8 plus negative 2 is positive 6. There are your two factors, x plus 8 and x minus 2. We'll take each factor separately, set them equal to 0, solve for x. Take the first factor, the x plus 8, and set that equal to 0. We get that x is negative 8. Same thing with the second factor, x minus 2 equals 0 if x is positive 2, and here are your solutions to the original problem. This even works when we have a leading coefficient that is not 1. For example, in this problem we have 2x squared minus x minus 3 equals 0. We need two numbers that multiply to negative 6 and add to negative 1. And you probably have realized that these numbers are negative 3 and positive 2. And as we've done before, we're going to keep the quadratic term and the constant term the same, and we're going to unsimplify the linear term. So that minus x is going to become negative 3x plus 2x. So now we have 2x squared minus 3x plus 2x minus 3, and we'll do 2 by 2 factoring by grouping. GCF of the first two terms is x. So we factor out an x. GCF of the last two terms is 1. We factor out 1 to have x times 2x minus 3 plus 1 times 2x minus 3. Please note that the two sets of parentheses are exactly the same. That is a requirement for us to go forward. If you did not get the two sets of parentheses to be the same thing, check your work. Because one of those is, well, that is one of the factors. And the other one comes from the two GCFs that we pulled out. So the one factor is x plus 1, the two GCFs. The other factor is 2x minus 3. That was the common leftover as we were doing the 2 by 2 factoring by grouping in the earlier step. Setting x plus 1 equal to 0 gives us a solution of x equals negative 1. Doing the same thing with with 2x minus 3 gives us a solution of x equals 3/2. Okay, it's your turn now. Solve x squared minus 3x minus 28 equals 0 by factoring. Hopefully you caught on pretty quick that the two numbers that multiply to negative 28 and add to negative 3 are 4 and negative 7. And since the leading coefficient was 1, we can drop them right in. We have x plus 4 as a factor. That gives us, when we set that equal to 0, when we say x plus 4 equals 0, that will give us x equals negative 4 as a solution. Take the other factor, x minus 7, set that equal to 0. That will give us an answer of x equals 7. Slightly different type of problem here. Now we have x squared plus 10x equals negative 24. And now comes a very, very important rule that you must follow. There is no such thing as solving a quadratic equation of this type without moving all of the terms to one side of the equation. You must get everything on one side of the equal sign before you factor. So one side must literally say 0, just like this. We'll add 24 to both sides to get x squared plus 10x plus 24 equals 0. And from here, the factoring job is really simple. Two numbers that multiply to make 24 and which add to 10, those numbers are 6 and 4. So we get x plus 6 times x plus 4 equal to 0. Each factor separately solved out. X plus 6 equals 0 if x is negative 6. X plus 4 equals 0 if x is negative 4. Here are your two solutions, negative 6 and negative 4. Here's another piece of practice for you. We have x squared plus 4x equals 12. Go ahead and solve that by factoring, please. Okay, the first thing to do was to subtract 12 from both sides to get x squared plus 4x minus 12 equals 0. Our two magic numbers that multiply to negative 12 and add to positive 4 are 6 and negative 2. So we get x plus 6, which gives us a solution of x equals negative 6, and x minus 2. When we set that equal to 0, we'll get x equals positive 2. We'll finish up with a word problem. Here we have this nice, beautiful rug. The rug at the right has a border of uniform width. That means that pinkish border is the same width on the left as it is on the right, as it is on the top, as it is on the bottom. In all cases, we'll call them X. The raspberry-colored field in the middle measures 91 square feet in area. Our question is, how wide is the border? How can we go about solving this? Well, it would be nice if we had two different ways of expressing the areas, the area of the center, and we actually do have two different ways. One of them is explicit. We were told that the area is 91. The other way comes from a little bit of algebra and realizing that the entire rug is 9 by 15. Whatever that border is, it's been clearly marked as having a width of x feet. So whatever this distance is here, this is going to have to be 9 feet minus an x minus another x. That's where the 9 minus 2x comes from here. And whatever this dimension is going across, it's the 15 feet minus an x here minus another x over here on the right. That's where we're getting the 15 minus 2x from. So we have two ways of expressing the area of this raspberry field in the middle of the rug. And we can set those equal to each other. And so we will. We have 15 minus 2x in one set of parentheses, 9 minus 2x in the other set, equaling 91. There's some work to be done here. We need to get everything to one side of the equation because we are dealing with a quadratic. As soon as we multiply negative 2x times negative 2x, we'll have a term of 4x squared. And so we are well on our way to a quadratic. When you FOIL the left-hand side, 15 times 9 is 135. 15 times negative 2x is negative 30x. Negative 2x times 9 is negative 18x, and those combine to be negative 48x. And then negative 2x times negative 2x is positive 4x squared. If you don't like seeing them in that order, we can put them in descending order. That's probably a little bit easier to work with if we put the 4x squared first and the 135 last. But it still doesn't fix the problem that we just talked about a few minutes ago, which is that we need one side of the equation to literally say 0. So we'll subtract 91 from both sides. And that will now give us 4x squared minus 48x plus 44 equals 0. We are well on our way. It's time to factor. And so I pose the question to you, what is the very, 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 very first thing you should do when you are factoring an expression? You should look for the greatest common factor, and the three terms on the left-hand side are all multiples of 4, so we will factor out a 4 and leave this as 4 times the quantity x squared minus 12x plus 11 equals 0. Now that 4, we'll let it come along for the ride, but it's not going to do anything for us because it is never ever true that 4 is equal to 0. That can't be. It's all about what makes the part in parentheses equal to 0, and that part needs to be factored. So the two numbers that multiply to positive 11 and add to negative 12 are negative 11 and negative 1. X minus 11 and x minus 1, when you FOIL those, you will get x squared minus 12x plus 11. That gives us two possible solutions, x equals 11 and x equals 1. But which one is it? Well, let's think about that, because when if we were to say that the width of the rug, or the width of the border was 11, we're putting a width of 11 feet here and here, which is the problem. That's 22 feet when we only have 15 feet to work with. And similarly, 11 feet here and 11 feet up here at the top would make another 22 feet when we only had 9 feet to work with. So 11's not going to work. But if we went with 1, if we said that this was 1, then we are saying that the raspberry field would have dimensions of 15 minus 2 times 1. That seems like 13. And the other dimension would be 9 minus 2 times 1. 9 minus 2 is 7. At the beginning, we said that the raspberry field had an area of 91. So if we took the 13 and the 7 and we multiplied them together, would we get 91? Sure would. So our answer is x equals 1, that this rug has a border of 1 foot.